Now, how much do we have to know about chromosomes and genetics?
No.
I was 9 when I started. Now, I admit it, I was trained by a plant breeder, but what I knew about chromosomes or genetics at that point, you could put into a thimble. So you don't have to be. You don't have to be a geneticist. You don't have to be a cytologist to do this. In fact, most people that do this aren't. We just like plants. But one of the amazing things, though, the chromosomes from Sempervivum range from 34 to 108, which is a huge range for a single genus. And even more amazing, they all seem to be able to intercross with each other. Now, sometimes the hybrids that you get from crossing these things with way different chromosomes aren't fertile themselves, but that first generation is. And so that's amazing to me. As any other plant group, you could never, even the irises, which are fairly homogeneous as a group, you could never begin to cross things with that kinds of different chromosomes and get hybrids out of them. So we are very lucky in the Sems. Now, as I said, you occasionally get things that have reduced fertility. The tufted types, which are crosses of cobwebs and non-cobwebs, those hybrids in general tend to be less fertile. Arachnoideum has like 38 chromosomes and Tectorum has like 68. And so that's a lot of chromosome instability. And so the hybrids produced much fewer seeds. But what you do get for seedlings are often very interesting from those plants. So oftentimes a hybrid that's come from two widely different parents gives just incredible seedlings in the next generation.
Is this what happens with one like Grunrand? I hope I'm saying it right. It produces almost no offsets. It's like just awful. You might get 1 or 2 offsets.
Right.
So I don't even know what the cross is and why this one is so difficult to get offsets from.
I would probably never use it as a parent because I want things to actually grow.
Yeah.
See it in my lifetime. So.
Because I've had it for 2 years, and I think I've gotten 2 or 3, and I have like 3 little.
I have Junimon, which is a sister seedling, and it's just buying a grower's. Not. But the amazing thing is you can get hybrids from these. An exception to this statement is that there are actually most of the stems are what we call diploid. That is, they have 2 sets of chromosomes. But there are some that have 4 sets of chromosomes. They're called tetraploids. And what tetraploids, you can cross tetraploids with tetraploids, and each parent gives 2 sets of chromosomes. So everyone has a partner to pair with, and that makes them happy. And those hybrids are exceedingly fertile. In fact, the one Sempervivum ex navadens from Spain, which occurs all through the Pyrenees, is a natural hybrid that was made from crossing of 2 different species like that. And it's very fertile, but because these chromosomes pair with each other and nobody else, they're very stable and very boring, because they always produce just the same old thing.
When you cross.
When you cross them.
No matter what you cross them.
Well, no, if they cross them amongst themselves.
Oh, I got it.
Yeah, they're always going to produce, because these chromosomes are very happy to pair with each other and not exchange information from these other ones, which is why we get nice things happening. So they're useful as garden plants. They're very stable, and you could grow seed from them and get lots of the same thing if you wanted to. But they're not as interesting in terms of getting something interesting in the next generation of hybrids. And then there's some general rules of thumb when you're crossing that reds and purples are dominant to green. So you put a red or a purple on a green one, you're going to get mostly red or purple, or occasionally that green with a red base combination. So that's a good thing. For those who don't want the green one, if you put a red one on it, even on a green one, you're going to get red ones, or red and green bicolors. Ones with tips tend to be dominant to ones without any tips. So if you get tip color, tip color on one and cross it with one without any tip color, you'll get all tip colored progeny. And cobweb is kind of semi-dominant but not cobweb. You get tufts on the leaves, but not a full cobweb. Size seems to go all over the place. There must be many, many genes that control size. That's not surprising. Look at the human population, how many different variations in height we have. And it's the same with these guys. And I think leaf shape is another one of those characteristics that seems to go all over the place. There's probably all kinds of genes for that. And that's one of the reasons we have such a whole segregation of things. However, I think the bigger sizes seem to be a bit more dominant. That is, when you cross a big one with anything, the progeny tend to be a bit bigger than you would say the mid-range of things. The only exception being the arachnoides, the cobweb types. They do tend to shrink the other side down regardless. They're fairly small. So how do you go about making a cross? It's really very easy. I did it when I was 9. So, in Oregon, all you need is one of these to be a hybridizer. When the plant looks like it's going to start opening its first blossoms, you just take the bag and literally put it over the top. I find that some of them you want to probably take a rubber band around the bottom, like so. And that keeps any insect from doing its thing. Now this is important for two things. You want to cover both the pod and pollen parent. Because the pollen parent, if you don't cover it, the bees are going to come and strip it of its pollen.
Oh, I never thought about that.
Yeah, so you have to cover both sides. But also, what I find, I'll make the cross in both directions. I'll put plant A on plant B and plant B on plant A.
And do you mark those so that you know which is the seed?
Yeah, now, if you notice, around the yard here, there are these little electric wires with different coating colors on them. Each one of those, I have a stud book where I write down that green with a white stripe on that little tag means calcareum or whatever. And I'll keep that so that every time I see a green tag, I know I put calcareum pollen on that particular plant. Then what I'll do is just keep these covered, and then you want to, on the plant that you're going to use as the pod parent, you have to pluck off all the little anthers with the pollen, which is the real tedious part. Number 5, tweezers. They have a very fine point.
Pointy. Where do you get those?
Amazon, you can get them. I think they're like $6, $7 a pair. Dumont number 5s. And they're stainless steel. They'll last forever. And what you do is you're going to take the flower, and you'll see that the pollen is yellow, so you'll know exactly where those anthers are. And you're going to take all of those anthers off the pod parent. Now, of course, you can use that pollen that you've collected on those anthers to pollinate on the other parent. But you also want to make sure that, because that pollen is so light and fluffy, it could fall over onto the stigma of the flower and pollinate itself. You don't want that to happen. So the structure in the middle here, that's where the seed capsules are now. That's where the female part is. So there's a cluster around the middle. See that cluster right there? You want to take your pollen and you want to rub it very gently on that structure in the middle. So there's a whole row of them. Depending on the species, it goes from 8 to 18. And they're all right in the middle there. So imagine that flower. Okay?
Can I see that a little closer, Karen?
Sure. So all that's
in this very center, I see that now.
So you want to just take the pollen and kind of rub it right around. So I usually take the whole anther on the end of those tweezers and just kind of run it right around that structure.
And
I
was looking at a blow up of
right.
a Sempervivum flower, And at some point, before the pollen matures, there's a covering, like a little shell,
Well, what I do when I on the
over the pollen.
the jodabarbas are kind of
Yeah.
they're pulled to the center like that. I pull all the petals off first before I try to do anything, and that makes life a lot easier. You can see all the structures that you need to see, whereas the semps they tend to bloom flat like that, so
Yeah.
all the petals are out, and so these structures in the center here are really obvious.
They're exposed.
They're
Yeah.
exposed and very obvious.
And you have to wait until the pollen is matured, and that
Right.
little coating is gone off of the little pollen.
Well, when the pollen is mature, you'll see it as yellow.
Yeah.
The anthers will what they call dehisce. They'll break open. It'll be yellow, and that's your cue. That's the time to pluck those off.
Got it.
The anthers, the pollen matures a day to 2 days before the stamens are ready to accept pollen.
Oh.
So when when you pluck the pollen off and you see that mature pollen, that means 2 days later you'll be able to pollinate that particular flower with the pollen of your choice. So you have about a 2-day window, and the stamen should be sticky. You put your finger down gently on that structure, you'll feel a little stick. And that's what also is going to adhere the pollen to that structure as well. And then you can just put the bag on for another couple of days. What I'll tend to do is to do a whole branch of these with the same, that way I can tie a twist tag at the bottom of the branch, marking what pollen I put on there, and that whole branch will then, I'll then have the same cross on it. And you'll get lots of seeds, as you'll see. Each one of those little stamens that you touch pollen to will form probably 8 to 10 seeds, and there are 13 to 18 on there, so you can do the math. You're getting quite a few just out of one seed capsule, so it's a lot. But you can also see why Ed didn't want to do this. When he came to take the lessons, he was like, "There's no way in hell, Kevin." I should tell you about some of these people too. I think Sempervivum people tend to be the most exotic of all the horticultural people. Ed was probably the king of the exotics. He owned a nudist camp in Ohio, and he collected Packard automobiles, and his favorite was a Packard hearse that he used not for hauling people but semps, and he had it the back end in tiers so he could take flats and flats of semps in this hearse, and he would arrive at these nurseries, hearse and all, with semps in the back. So he was, as I said, an interesting character. Okay, we got our making the crosses. It's really not that bad, though. I mean, it sounds, as I said, in Oregon, it's really not. It's not as much of a chore. You don't have to do all the elaborate. I should tell you how I actually got into this. My neighbor was Polly Bishop, and she was out there one day with all these muslin bags and cages and everything else, and I was riding my bike by, and even then I was a science geek, so I pulled into her driveway, and she proceeded to show me what she was doing, making these crosses and all, and she said, "Come back tomorrow and you can make your own." I was there. And Patty Brown was my same age, and I told her, "I'm going to make crosses tomorrow." She says, "You think I could make crosses too?" She said, "Oh yeah." And so she came down and she made crosses. And that was how it all started. And from our first crosses, we actually put things on the market.
That's so amazing.
And so, I mean, of course, it's nice to have a person who had a collection of every semp then available and had all this training and plant breeding to lead you on. You just don't stumble into something like this, as you'll see. Now, there are other approaches to hybridizing. In fact, Helen, now that she's passed, I can tell you the awful story of how her hybrids came about. There was every time she would get low on certain plants, she would send to this one nursery in Ohio to get more of a particular cultivar that she needed. Well, that particular nursery in Ohio didn't do a very good job about taking out the flower heads and starting getting out the plants and things. So when they arrived, they would always have rings of seedlings around them. And so she would just, being the frugal Mennonite that she was, she couldn't throw them out, so but she separated from the mother plant and put them in a row, and all of her hybrids were just ones that she pulled off out of this. And so Lavender Olace, which won the gold medal from the Sempervivum Society, was something she pulled off one of Sandy McPherson's plants that he had sent to her. He had sent her a Laura Lee, and it had all kinds of seedlings around it, and that was how she created her hybrids. She did grow some from seeds subsequently, but it was, as I say, now that she's passed, she just never tell anyone this story. So I'm sure I'll be haunted tonight. Now, Ed, of course, was the other extreme of the situation. He loved Semps, and there was no Semp he did not have. I think he had 3,000 or 4,000 in his collection before he passed. And he literally just took the hedge clippers out when they matured and collected them all and put them in a big shoebox and planted them out. He ended up selling seed to Thompson and Morgan, and so that was a lot of the American hybrids were actually out of the seed that Ed gathered in his yard. He had quite a number of them. So, but it also speaks to the point that it is a numbers game, and that the more you raise of any cross, the better your chances for getting really good combinations. And when you raise that many, just by dumb luck, you're going to get some that are pretty good. And he just certainly did very, very well. Some of his hybrids are certainly the best in the world. Now, Polly Bishop was my mentor, and she's the one that actually taught me the proper way to do all this. But about midway through her career, she also decided that this was a real pain in the butt to do this. So, but she was trying to get a black Sempervivum, and what she did was to take all the seed heads from all the darkest Semps in the yard and put them together and crisscross the stalks so that they were like this. And she noticed that when a bee would go on a clump, it would tend to follow a clump, but when they were crisscrossed like that, it would go jump from one to the other and back again. And so she made these little circles of all these Semps that were the darkest ones.
And she literally cut the blooming stalks off?
No, she dug the plant up.
Oh,
okay, she dug the plant up. She dug them up and made them crisscrossed. Yeah, weigh it down.
Yeah.
And she put these little crisscross arrangements because she said we don't actually know what makes a really dark Sempervivum because we don't have the genetic knowledge. And so by just taking all the different dark ones, putting them together, the bees would cross every combination of those parents. Then she took the seed from those and raised out a big progeny, 2,000 or 3,000. And that's how Dark Cloud and Plum Rose came to be. By just taking all the very darkest Semps of the time, putting them together. And you can do it even on a smaller scale. I mean, you could put two Semps that you particularly like together that you want to make a cross, put them together in a bed. I think crisscrossing them, as she said, the bees tend to follow patterns, and if you disrupt that pattern that they make by crisscrossing them, they tend to cross one to the other rather than go right along the same parent, so that you facilitate crossing one variety with another. And it worked. She got Plum Rose and Dark Cloud.
And she knew her bees.
And she knew her bees, that's right. So that's a very simple way of making crosses. It's a little, I think it's a little more educated than Ed's. You know, you really have, you're improving your odds, and that's the whole, instead of having to raise 30,000, she raised 3,000, and got some really nice stuff.